What's up, y'all? Thanks for tuning in. Today, I want to talk about another fundamental slingshot concept, band tapers. Now, most of us who shoot flat bands will shoot tapered bands. If you buy your bands pre-constructed, like a lot of people do, this one is a pre-constructed band, it almost certainly comes to you already cut on a taper. If you tie and cut and tie your own bands, you probably already have your specific desired taper dialed in exactly. This is not a video about which tapers are best for which applications. Uh, Everybody has their own different desires, their own use cases, their own band tapers that work best for them. Instead, this is a video that is going to explore the concept of why we use band tapers at all. Uh, I think most of us sort of intuitively understand that a tapered band will shoot a piece of ammo faster than a straight cut band will. Uh, but I'd like to get into why that might be the case. And I'll do so by doing a little demo here in a second. Before I do that demo, though, let's talk about exactly what a taper is. Simply put, a band taper is when your latex band is cut wider at one end than at the other. Not thicker this way, but wider this way. And always wider at the end that attaches to your frame than at the end that attaches to your pouch. I'll show you that this is actually a tapered band. It's not an extreme taper, and it may be hard to tell with me just holding it up here. But if I fold it in half, it becomes pretty easy to see that the side that attaches to the frame, the one that's closer to the camera right now, is quite a bit wider than the side that attaches to the pouch. And that is a tapered band. But I'm not going to use this pre-constructed band set for the sake of the demo. Instead, I have cut myself two individual bands, unattached to a pouch, unattached to a frame, just a band. One of these is a straight cut. And if I fold it over here, you can see that the two ends are the same width, and it is the same width throughout. This is a straight cut band. Okay. This one, however, is a tapered band, and if I fold it over, you can see that one end of it is significantly narrower than the other end. That's a tapered band. Okay, the next thing I'm going to use for this demo is this yardstick. I wanted to call it real big ruler there for a second, but it is in fact a yardstick. It is 36 inches long. And I'm going to start by attaching the straight cut band to the yardstick. And I'm going to show you real quick that I have cut this to 9 inches long. And I cut it to 9 inches long, not for any reason other than that when I extend this all the way to 36 inches, it will be extended to 4 times its original length. And that's just going to make the math easier later. There's a very little bit of math later in this video, and I apologize in advance for that. The other thing I have done here is I've placed a mark right in the middle of the band at 4.5 inches. 4.5, half of 9, that's right in the middle of the band. Now, I'm going to stretch this band over the course of this 36 inches. But before I do, I want you to think for a second about where this line is going to end up when this band is fully stretched. Will it still be in the middle of the band, which, when stretched to 36 inches, is going to end up being 18? Will it be slightly closer to this end? Will it be slightly closer to this end? In this demo, by the way, the already attached side is the frame side, and the not yet attached side is the pouch side of the band. So is it going to be right in the middle at 18 inches? Is it going to be closer to the frame, or is it going to be closer to the pouch? Got an idea of what you think? Let's find out. Okay, here we are. We have a band now stretched out to 36 inches. And if we look up close here, we can see our line right at 18. It is exactly in the middle of the completely outstretched band, which makes sense because there's an equal amount of latex on one side as there is on the other, so the middle should stay the middle. Cool. But an interesting thing is going to happen. In a minute here, I'm going to open up this clamp, and I'm going to send this end of this band shooting over that direction, hopefully avoiding my fingers in the process. And when I do that, let's talk about what's going to happen. This spot in the band, which is currently sitting at 18 inches, remember, it started at 4.5 inches, which means in order to get from where it was to where it is now, it had to travel 13.5 inches, if my mental math just now was correct. Okay, so it traveled 13.5 inches from rest to stretch. And when I snap this band back the other way, it's going to have to travel that same 13.5 inches back from here to here. But the far end of the band that's currently sitting at 36 inches, remember that one started at 9. In order to go from 9 to where it is at 36, that had to travel 27 inches, twice as far. And therefore, when I open this clamp and snap it back the other way, it's going to have to travel that same 27 inches to get back to its resting spot. Again, twice as far as the midpoint has to travel. So think about that for a second. How does one thing travel 13.5 inches and another thing travel 27 inches in the same amount of time? And the answer is because it's moving faster. This end of the latex has to travel at a faster rate in order to get to its original resting point than the midpoint of the latex travels in the same amount of time. And that is what will cause a ball to go shooting out the other direction when I do this. Okay? Had there been a ball attached to this end of the pouch, it would have gone shooting that way because of the fact that that end is traveling so much faster than the rest of the latex. Now, let's do that same demonstration, but let's do it with the tapered band. By the way, this band is cut on what we call a 2012 taper, and that just means that this fat side is 20 millimeters wide, and this skinny side is 12 millimeters wide. This is an extremely common taper. You'll see a lot of people shoot a 2012 taper. I am not using this for any reason other than that it makes the math work out pretty nicely. that you'll see here in a second. I am not telling you that you should be shooting a 2012 taper. It's very common, but there are lots of other very valid tapers as well. So we're going to attach this tapered band to the yardstick in the same way that we attached the flat band to the yardstick. And I will show you, just so that you don't think I've cooked up this demonstration, that we are at 9 inches, the same, and we have a line at 4.5 inches, the same as the flat band or the straight cut band. Now, before I stretch this out, let's think again. Where do you think this line is going to end up when I'm at full stretch? 36 inches. Is it, like the straight cut band, going to stay right in the middle at 18 inches? Is it going to be a little bit closer to the frame? Is it going to be a little bit closer to the pouch? Think you've got an answer? Let's find out. Okay, here we are at full stretch. Now, where is that line? It is right around 16 inches. It is just a little bit closer to the frame than it is to the pouch. Now, remember in the example of the flat or straight cut band, rather, we did the math for how far each bit of the band had to travel. Let's do that again. Okay, this midpoint, which just like the flat cut band started at 4.5 inches, is now at 16 inches. So it traveled 11.5 inches. Remember, in the case of the straight cut band, it traveled 13.5 inches. For the tapered band, it only traveled 11.5 inches. It traveled less far. And therefore, when I snap this back and hopefully avoid my fingers in the process, it will also have to travel less far back to its original resting place at 4.5 inches. It will only have to travel 11.5, not 13.5. However, this end of the latex is still all the way out at 36. It traveled the same 27 inches to get here as the straight cut band did, which means it has to travel the same 27 inches to get back to its original resting spot as the straight cut band did. So now we have one spot in the band, the middle, or what was the middle anyway, traveling 11.5 inches in the same amount of time as the end is traveling 27 inches. So in the case of the straight cut band, the end of the latex had to travel twice as far in the same amount of time. Now, with the tapered band, it has to travel more than twice as far in the same amount of time. 27 is more than twice 11.5, which means that in order to end up at their respective resting points at the same time, this one has to travel now more than twice as fast. Faster than the straight cut band did. So when I do this, and I did not hit my fingers that time, had there been a ball attached to this end of the pouch, it would go shooting off that way even faster than the straight cut band did. Okay, that's pretty much the demo, y'all. Not much more to it than that. So I hope that was useful. I hope maybe you learned something today. Thanks for tuning in. Bye.